All right, let's cover sections 8.2, 8.3 over dividing monomials. Remember, monomials is just talking about no additions, no subtractions so far. When we divide monomials, we're going to have another rule, just like we did with multiplying. Remember, with multiplication, it was keep the base and add exponents. So that's why x times x times x times x times x becomes x to the fifth, because you would do 1 plus 1 plus 1 plus 1 plus 1 to get x to the fifth. Now that we're doing division, when we go ahead and expand that, then what we need to be looking at is now, every time we have x over x, just like if we had 2 over 2, it's going to become a 1. So we have 1 times 1 times 1 times x times x. So our answer here is actually x squared. Now, just like we had in our last section, now we're going to have a rule or a shortcut. I hope it's obvious to you, but in case it's not, the rule is keep the base and subtract the exponents, because 5 minus 3 is 2, and there are two x's remaining in the numerator. Now, if we think about the same idea, now we go to our next rule, raising to the 0 power. We know that x to the fifth over x to the fifth, if we were to apply that rule we just learned, we keep the base of x and we subtract the exponents. We would do x to the 5 minus 5. That would be x to the 0 power. But I want to look at it the expanded way first. If I look at the expanded method and I look at all of those x's, it's the same as doing keep the base and subtract the exponents. So we end up with x to the 0 power if we use that rule. But what happens if we do it the long way? 1, 1, another 1, another 1, times another 1. And if I do 1 times 1 times 1 times 1, well, I'm always going to get 1. And the rule for raising things to the 0 power says that any base raised to the 0 power is equal to 1. Now this rule is one that we set you up for some common mistakes and some trick problems. So when we get to the examples, I'll show you those trick problems in just a moment. Now the last piece is this idea of negative exponents. I'm not really a fan of doing a problem that's written as a fraction without negative exponents. I'm not really a fan of introducing them. But let me show you how it would look in my opinion if I were writing math books. I would tell you that this problem appears to be bottom heavy, that we end up with 3 x's being multiplied together in the numerator, and we end up with 5 x's being multiplied together in the denominator. So when we start doing this simplification or fraction reduction, we end up with 1 times 1 times 1, but in the denominator there are 2 more x's left, so that we know that this is going to be an x squared in the denominator. And since we can't ever leave an empty numerator, that 1 doesn't get to go invisible. It has to be visible, so 1 over x squared. Now if we were using that subtraction method, we would keep the base, we would do 3 minus 5. That would give us x to the negative 2 power. But we are never allowed to use a negative exponent in an answer. We're still allowed to have negative numbers, but we're not allowed to have negative exponents. So you need to take this negative 2 exponent and make it positive. The only way to make it positive is for it to change sides of the fraction bar. So whole numbers are usually in the numerator. So now that this x, this base with x, goes to the denominator and becomes positive, and now my empty numerator has to get filled in with 1. It's kind of an awkward rule. We're going to see lots of practice problems, and I know we're going to do some in class together with negative exponents. But here's the rule for you before we move any further. it says a negative exponent changes the base to the other side of the fraction bar and becomes a positive exponent. A negative exponent changes the base to the other side of the fraction bar and becomes a positive exponent. All right, let's go ahead and use your calculator to evaluate those things and then come back and talk to me. So take a second, grab that calculator and check them out. All right, so hopefully you put these into your calculator and you got the same answers that I did. I'm going to read mine from bottom up. I have 10 squared is 100, 10 to the 4th power is 10,000, 10 to the negative 2 should be 1 over 100. Or if you have the decimal 0.01, 0.01, that would also be acceptable. And 10 to the negative 4 is 1 over 10,000. If you have 0.0001, that should also be okay. And 10 to the 0 power should be a 1. So hopefully you have those all filled in. All right, so let's go ahead and let's look at some of these basic ones. I think I'm going to do a second video for the more complicated examples, but I think these first ones we can do with no problem. So when we take y squared over y, this base of y has an exponent of 2, this base has an exponent of 1, it's top heavy, so we end up with y to the 2 minus 1, so that's just y to the 1st or y. The denominator becomes empty because we can eliminate. X to the 9th over x squared. So that's really keep the base of x, and we'll do 9 minus 2, so that's really x to the 7th. All right, keep our base of 3, and to the 10 minus 4, so that's really 3 to the 6th power, and that's one that we can just leave as a number. 5 to the 4 minus 2 exponent, so that's really 5 squared. That's one that we cannot leave, so we have to change that to 25. Again, I want to start on these next problems, but I think I'm going to use a second video starting at number 7. So let's look at this again. All right, we have like bases, but we have to treat them separately. We'll do the x's first. X to the 5th over x to the 5th, well, those will become a 1, right? A number over itself becomes 1. So now we really only have to deal with the y's. Y to the 3rd over y squared is going to become y to the 1st power. Starting at number 6, when we have a number in front, remember that those are still just a fraction. This is still a fractional value. So we treat those bases just like it were a fraction. So 15 over 45 gets simplified first. 15 and 45 are both divisible by 15, so that we simplify that to be 1/3. Now we go to the bases of y, and we're going to keep the base and subtract the exponents. So y to the 3 minus 2, or we can think of this as being top heavy in the y's by 1. So we end up with 1y over 3. Again, I'm going to start a second video for finishing up these examples.